Welcome to the 8th grade Math Homework Helper Series. Tonight's homework is SP-4, Writing Equations for Lines of Best Fit. We'll start by reviewing. There are four types of scatter plot associations. We could have a positive association where the data is moving from left to right in an upward direction, a negative association where the data is moving from left to right in a downward direction. We can have no association where the points are just scattered all over, and a nonlinear association where it's moving in a non-straight line kind of form. Synonyms for the word association. You may see correlation, trend, or relationship used in place of the word association. They all mean the same thing. A trend line is a line that most closely represents the relationship between two variables in a scatter plot. It may also be called a line of regression or a line of best fit. To construct a trend line, you should use a straight edge to draw a line that passes through the points so that there are an equal number of points on either side of the line, or as close as you can get to that. The line may or may not pass through any of the points. Most of the time, the line will be a positive or negative and represent the association between the two variables. Writing an equation for lines of best fit. The equation for a line of best fit is written in slope-intercept form, or y equals mx plus b. You will need to use the data given to determine the slope and the y-intercept, and then plug them into the slope-intercept formula. And let's go ahead and get started on that. We're starting with question number 4, and it states that Joey kept track of the number of free throws that his team shot in practice and the percentage they made in the next game. He displayed his findings in the scatter plot below. And we're going to start by drawing a trend line on Joey's scatter plot. So I've placed my line right about here, and I have a similar number, a few more on top than on the bottom, but a similar number of points above and below my trend line. So A, finished. Name the type of correlation that exists. Well, moving from left to right, I can see that I'm moving in an upward direction. So that correlation would be a positive correlation. Does the trend line show a linear or nonlinear association? Well, it is maintaining a straight line, so I would call it a linear association. But it is kind of weak. It does spread out a bit here and here. So you can note that it's a weak association, but it is straight. And that brings us to writing an equation for your trend line. So the first thing that we need to do is we need to pick some points on here. The points that I've chosen to work with are 2550 and 175.90, both of which can be found 2550 right there and 175.90 right there. As it turns out, both of those points are on my line. Now I need to determine the slope. You're going to have to reach back in your memory, and you may remember that the slope formula is y2 minus y1 over x2 minus x1. So using the points that I took, I have 90 minus 50, and I have 175 minus 25, which gives me 40 over 150, which boils down to 4 over 15. So my slope is 4 over 15. And now that I found my slope, I need to find my y-intercept. Using y equals mx plus b, I plug in an x value and a y value. So I took the 2550, plugged in 50 for y, 25 for x, and I was able to cancel out the 15 and the 25. That reduced down to a 3 for my 15, a 5 for my 25, and so that gives me 50 equals 20 over 3 plus b. I then took 20 over 3 and converted that to a mixed number, which gave me 50 equals 6 2/3 plus b. Moving from there, I subtracted 6 2/3 from each side because my goal is to isolate b. That canceled these two out, and it gave me b having a value of 43 1/3, which I can state for my y-intercept. Once I have my y-intercept, I can then go ahead and create my equation. So using y equals mx plus b, I have y equals 4/15 x plus 43 1/3. Now that I have that equation, I can use that to solve the last part of this problem, which is a student takes 60 free throws during practice. Using your equation, predict the free throw percentage that the student is likely to have during the next game. Well, if we take a look back here at this graph, we can see that free throws are on the x-axis. Percentage of success is on the y-axis. So she's given us 60, and that's for free throws. So if we plug that into this formula, we're going to want to do that as an x value. So let's pull this out and take a look at it. So here's the original formula, the original equation that we came up with. I have plugged 60 in for x, and then I was able to, using cross product, divide 15 and 60 and bring that down to a 4 and a 1. So that gives me 4 times 4, which is 16 over 1, or y equals 16 plus 43 1/3. If I add 16 and 43, that gives me y equals 59 1/3. Taking that information, I can now state as a sentence, because it is a word problem, that the free throw percentage is about 59% when 60 free throws are taken at practice. And now that I know that the answer is about 59%, I could take a look at the graph. And I could have taken a look at the graph first, I suppose, to get an idea of where my answer should fall. But if I look down here, 60 free throws would be somewhere in here. And if I move up to where my trend line crosses, it is pretty much at about 58, 59. So my trend line is pretty accurate. Now, this could be misleading, I suppose, if your trend line was wrong or you didn't put it in a good spot. But between the two, it should help you to figure out, A, before you do the work with the equation, it can give you an idea of where your answer should fall. And when you do get your answer being more accurate can help you to understand if you put your trend line in the right place. And we'll move on to number 7. Describe what a great line of best fit looks like. Well, a great line of best fit should follow the direction of the data points. It should have the same number of points above and below the line, and if possible, it should ignore outliers. And lastly, we have draw, for number 8, draw 2 scatter plots that could be represented as a nonlinear association. Well, the most common that you see is the quadratic or arced line, and that could go in either direction. So either one of those could represent a nonlinear association. This isn't to say that these are the only 2 answers for this question. There are many different kinds of answers for this question. The key is that the points that you plotted can't be connected with a straight line. As long as that's true, then you've pretty much represented a nonlinear association. Please use the work that was done for you tonight to help you to solve the additional problems that are on your homework. And remember, the key to success in math is not only working hard, but working smart.